Okay, welcome. In this video, I am going to show how you could scrape or grab a bunch of data from a website using Python and then combine it to make sort of a glossary or dictionary that's illustrated with images from another repository. Okay, Kelly, here we go. So the first thing we need to do is I need to explain that Kelly wanted to create a website to help her students with architecture, understanding architectural terms. And she's got big plans, but the first part is she wants a glossary for her students to use, and she wants to design the look of it because some of them out there on the web, they're good, but they're really busy and they're old. Because apparently there's not a lot of money for supporting those glossaries, or she doesn't want them on the web on their own at that point in her class. So first thing we should do then is we should find, let me close this for now, a glossary of architectural terms. So Wikipedia has one. And now we could copy each term and paste it in a Python list, and then copy the definition and paste that in and connect them, and do that for all these terms. But that's not very Pythonic, right? Python lets us look at a website and with a few lines grab all the stuff we want and format it for us. So what we need to do is we need to figure out how these are formatted. A lot of times you'll just be looking like each one of these will be a new paragraph. And so that's the way you'll get it. You'll just be like, for every time the Beautiful Soup package finds a paragraph, just grab the text inside of it. So let's see if that'll work here. Let's go to Web Developer and Inspector. Okay, you will notice that, well, do you see a lot of paragraphs? I don't really see any paragraphs. I see, oh wait, here's one. This page is a glossary of architecture. Well, that's not very, we don't even need that, right? We know what it is. We need the terms. So when we look down here at these terms, what do we get? See how it highlights it when I click on it? It looks like it's in a DT tag within a div class of glossary. So the DT, instead of P, we might be looking for DT. And then where's the definition? Come on. It looks like the definition is in the DD class. So we've got the, we also have a DFN class. Anyways, we've got the DT and the DD. And so every time there's a DT for aisle, then there's a DD for the definition of aisle. So let's see if we can use those. First thing we need are a few packages we're going to be using. So let's put those in. Okay, so we've got requests and Beautiful Soup, which is bs4 is the fourth version of it. First thing we're going to need is, we're going to make a function. So let's call it get Wikipedia text. And then let's explain what it is. And I don't go very fast, so you probably want to watch this at ×2 speed. You might be wishing that you could watch it at ×3 speed. Oh well. Okay, so then first thing we're going to, so you'll notice up here, we've got Wikipedia text, and the text URL equals that Wikipedia site. So this is just by default. So now I don't have to add the URL into when I call this function. It already knows that if nothing gets passed, just automatically use this. So you could use my function and just not use this, and it would go wherever you want to go. But also remember that we are we're optimizing this for Wikipedia, for this specific page of Wikipedia. So it might not work. You might have to use the inspector to find the element names that you need. Okay, so we're putting in this print checking URL for elements just so that, you know, as we're testing it, we know where it is and what it's doing. Okay, so you notice when I pasted this in here, requests went from gray to colored up here. And that's because now we're using it. So it's like, I'm active. But HTML is still gray because we're not using it yet. It's just going to hold. So what this does is it goes out to the web, it goes out to this URL, and it gets all that's on that page in text format. Okay. Then we need to grab the beautiful soup. So this package now lights up because we're using it. So we're creating an instance of beautiful soup, and we're passing it this HTML variable that holds the entire text of the web page, including all the tags and everything. And then we're saying the format we want is LXML. Okay. Then what do we want that beautiful soup object to find? Well, we want it to find all of the DTs and the DDs. So now we've got this instance and it's got everything in it. We can use the beautiful soup methods. And so we're going to use this find all method. And we're looking, so on a normal web page, we look for the Ps, look for the paragraphs. But we know that it's not going to help us. We need the DTs. So that's why we've got DT in this quote here, and it's going to make a list of all the times it finds a DT, and it's going to put everything in there into this list. And then guess what else we're going to need? Yep, we're going to need the DDs. So let's just change this. So now we've got two different variables, and let's see how long they are. Oops, excuse me. Let's print them like so, to see if they're the same length. Because what if like they used a DT or a DD for something else inside of this document? We'd want to know, right? Okay. And now what do we need to do? And let's return those two lists. Let's return the found DTs and the found DDs so we can look at them individually, inspect them if we need to. Okay, now let's come down here and let's just make a variable to hold our information, and let's call this function get Wikipedia text, and we don't have to pass it a URL because there's one, we've got the one we want as the default. Okay, let's run it, see what happens. Okay, so it checked for URL for elements, and we found 237 DTs and 240 DDs. So you can see what the problem is, right? They don't match up. So somewhere in there, and maybe for both, there's some extra thing that's an issue. So then we can do it two ways. In PyCharm, we can come over here, and here we have our variable. This is a variable explorer. And so then we can look at the 0th item in this list are all the DTs. And so here they are in this long list. It's not very readable, is it? Okay. And then here are, oh, we could look at it this, oh, this might be easier. Look at that. Okay. So let's look at these DTs. So the first one is abacus. That's good. Yep, those are all good. I'm just looking to make sure that each one has a term in it. Yep. This is probably the fastest way to do this. I suppose we could run a piece of Python on it, and that would be faster. Okay. This is more visual, still good. I don't need to read them all. I just need to see that they're all what? Huh? Okay. 237. 236, but plus the 0th one. Okay, so that seems, wait, what's this one? Scroll? Yeah, scroll would be a thing in architecture, wouldn't it? I'm just looking through it twice. Oh, wait, look at these. This is just an empty string, empty string, empty string, empty string. Those aren't going to be useful to us. So we're going to have to do something about that. Okay. So what about, so now we know we've got to deal with empty strings for the DT class. What about the DD class? What's going on in the DD class? In the DD class, oh, look at this. 1, 2, and 3, raised panel, open portion. Let's go back to our website briefly. Look at this, apron. It's got 3 definitions. So that's going to be a problem. We could either combine all these in one, or we could just take the first one. Huh. Okay. So we can't just use it because 1, they don't match up 1 to 1, and 2, both of them have some issues. Are there any other issues in here? Are there any like, oh, here's another 1, 2. Okay. Oh, okay. Ancient Greek. Okay, so these are pretty much behaving. I don't see any like empty ones. Like some of them have like a redirect to a new page, but that's okay. It's still just a web link within the definition. Okay, so these are all DDs, but there are a couple times when there's a list, and then that throws us off because if we try to match them up, the 0, 1 with the 0, 1, eventually we're going to get to the list where you've got multiple numbers, and it's going to go to the next glossary term. It's going to jump it. So we don't want that. Okay, so we're going to have to do a little bit of extra work. Now, this extra work is only going to be useful for this type of web page. In fact, it might just be useful for this web page itself. Okay, so now we're going to need a way to, so up here, let's make a new function. We're going to need to sort of cull so let's call it cull DTs and DDs. Okay. What does it do? Oh boy, what's going on there? Takes a list and removes alternative meanings or definitions or empty strings, because we've got both, right? Now, should we combine them into one? Well, it means that I think it might be useful to run both possibilities on each one. So let's do it that way. Okay, so what we want is we're going to repopulate. So we're going to make a new list. Let's just call it new list. We're going to take this past list. And so we're going to take each of these, the found DTs and the found DDs, and we're going to pass them up to this function. And then the list that gets passed, the found DTs or DDs, we're going to look at each one, see if it has the issue that we've spotted. If it does, we'll do something special. Otherwise, we'll add it to the new list and we'll spit the new list back. And that'll be the new DT list and the new DD list. Okay, so let's do for item in past list. So for each item in this list that got passed, which is going to be the found DTs or the found DDs, what should we do first? Let's do the empty ones first. If the length of the item.text, so the item in the list has more than just text, but we only want the text. We only want whatever's in extra those brackets. See all the stuff down here? So we don't want any of this glossary ID, blah, 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 style, etc. We just want the one word, wherever it is here. We only want to bring back what's between these tags. That's the actual text that's shown on the screen of the web page. All the other stuff is nice. It makes it look nice and formats it, but we only want the word itself. So that's why we add .text to it. Okay, so if .text, the length of .text, so the character length is less than 1, that's going to be in that DT case. Remember when there were a couple that were just blank? Then we just want to pass. We don't want to do anything. Okay. Come on. There we go. Now we want to else if. So elif. So it'll look at both of these. It'll first look at this one. If this isn't true, it'll go to the next one, which is elif. Oh, my dog's at it again. Okay. Elif. And what do we want to look for there? We want to see if item.text 0. So this means the first character in item.text, the very first character. If the very first character is a 2, a 3, or a 4. So remember when we were looking at, oh, let me scroll back. When we're looking at the DD class, come on, there we go. The DD class, the only time a number was first was when there were multiple definitions for the same word. Okay, so we're going to handle this in just a quick way. I'm just going to worry about the first definition and not grab the other ones, but you could do this in a different way that would, be a little more elegant. But so we're just going to ignore anytime there's a second, third, or fourth definition. We're not going to add it to our list. So yep, we're going to write pass again. Okay. Come on. There we go. So you'll notice that we're first checking for exceptions because we want them to be ignored. So if there's no text, ignore it. So what that does, the pass means that it doesn't keep looking for matches. It goes up to the top and starts over in this for loop for the next item. So if either of these two match, it's not going to add it to our new list. Else, so for all the other ones, then we're going to add it to our list. So new list append and then item. There. Okay, now we're appending the entire item, not just the item text. We could append just the item text, but we're going to do that later. Okay, so now we've got the new item in it, and then we're going to come down here, and after this is all done, so after it goes through for every item, remember here we've got all these, we've got like 200 and some items for each one. So after it's done running this test on each item and making this new list, then we're going to return. What are we going to return? Yep, we're going to return this new list. And we can save that new list as a new variable. So down here we have found DTs, and then we have how long they are. So then if we go here, let's call it the called found DTs or the called DTs. Okay. So let's paste that in. Called found DTs. Let's just call it called DTs. And we want the right function name. Okay. So called DTs is a new variable. It's going to hold whatever happens up here. It's going to hold this new list that's returned based on the found DTs. Okay, so then we can just copy this one. And underneath the found DDs, yeah, let's give us some more space. Let's put this in there and let's call this the called DDs. And let's pass it the found DDs. Okay, so now we've got these new lists. We think they're going to match up. The fastest, crudest way is going to be to print their values. So print the length of the called DTs, and then we can come here and print the length of the called DDs. Okay, so let's run this again. See how it works. Okay, so we've got the original number is 237 and it goes down to 235 for the DTs, and the original number is 240 for the DDs, and it goes to 235. So the 235 and 235 match up. Could there be some other weird problem? It's possible. But if we go, so to check that, we could go into R. And so if we go R, so the first one, so R0, oops, just slow. R0 equals the whole thing. So let's do R0, 0. That should be the first item. Yep. So if we did R0.0.text, then that's just the text. Yep. Okay. Now, the first one's probably going to match, right? I mean, we might as well check. Let's go back here in that second list. Flat slab forming the uppermost member division of capital or column. Is that right? I'm not architectural. Here's the first one. Abacus, flat slab, blah, blah, blah. Yes, it is. Okay, but the first one's going to match, right? Let's try the last one. So we can use this. Oh, let's go there. We can do this thing where we still want that, but here, let's grab the last item. We just -1 grabs us the last item. Ziggurat. And then if we do the same thing in that second column, -1 grabs the last, a temple tower, ancient Mesopotamian valley. And let's see if that matches up. Ziggurat, temple tower, etc., etc. Okay. We could test the middle one, but let's just say we've got it. So far this works. We have the two lists, right? Now what do we want to do? Now we want to combine the lists, right? So let's make another new function. And let's call this function combine lists. And then we've got the term list and the def list. Takes two lists and combines them by position. Okay. So the first thing we want is a new list. So we've got a term def list. Now, this could be a dictionary. The dictionary might work better, but we're going to use a list. Okay, so then we need a counter equals 0. Because our list starts at 0, we want our counter to start at 0. And then we want to check. And then, yes, that's what it's going to be, but let's call it term list. If the length of the term list and the length of the def list are equal to each other, because we don't want to try this. We don't even want to do this if the lists aren't the same. They have to be the same length, otherwise it won't work. So let's check that out. And then let's go down one and we'll put in else. And let's just do a print and say there's a value mismatch between past lists. Okay. Next up is combining the lists. So let's do while I is less than the length of, no, not the term def list, term list. Okay, because we know these two are the same length, so we just need to get one of them. While I is less than that, because once it becomes equal to it, it'll be one above because it starts at 0, right? So then we're going to go to term def list, append. This is pretty simple. Might not look simple. Let's grab term list here. and def list here. Okay, and then we want to increment the I. Otherwise, it'll just run on the I will always be equal to 0. I equals I plus 1. So what this does is it takes I has a value, a numerical value, and I counts up every time. This is just a loop, keeps running and running and running until I is no longer less than the length of the term list. Okay, so then what we've got is we've got this new list, the term def list. We're going to append the term list in location I, just the text of it, and the def list in location I, just the text of it. So these are going to become an item, a list of 2 items within a list. So it's going to loop through the entire lists and combine them. And then what are we going to have it do then? We're going to have it return, yep, term def list. So notice we set it up here. So if these aren't equal, then it'll skip all this and it'll print out the mismatch, and then it'll return this empty list. Okay. So now that we've got this combined lists construct, we can use that. So we've got the called, we can use the combined lists down here. So now we know that they've been called and what they equal. We could comment these out now that we know. And we're going to need a value for this, right? Oops, come on. Term def list. Okay, so if our, come on. Equals. Sorry, my puppy came in, needed some reassurance. Okay, so the combined lists, we need to send the called DTs and the called DDs. Now, this is the same as the term def list, so we could name this something else just so it's not confusing. We could call it the combined list equals that. Okay. And then with this get Wikipedia text, now we probably don't want to return these because we don't need that anymore. We just want that combined list returned. Okay, let's run this now, see how it works. Okay, special values, let's look over here. Now we have a single list, and you'll notice that each element, so the first element has 2, so maybe it's easier to do it here for a second. R0, what do you think R0 is? Remember last time R0 was that whole, like everything in all the DTs. But now our R0, our first element in this list, is the first term and the definition for that term. So then we can do R00, and we don't have to do .text anymore because we already did that. And if we do R01, we're going to get the definition. Okay, so that's a lot easier to work with now. Okay, the next video in this mini series is going to be, all right, now we've got that, how do we add images? How do we take this list and look for images?